Now we will continue with the meshing tools and also some more geometry optimization tools. Let us understand that with some more tools. So now what we will do is we will mesh the geometry that you can see on your screen. Okay. So let us go to the software part. Okay. So the geometry has been imported into the design modeler. Now what we are going to do is we are going to mesh this geometry. But if you see this geometry very closely, there are some features like there are some holes, there are some slots, there are some cutouts over here. Now if you look at the geometry very closely, the geometry is a very complex geometry. So meshing this geometry will become very difficult. Now previously when we saw the example of a clamp where we use the slice tool to create the hexahedral elements. Now in this case, creating hexahedral elements won't be possible because it is a very complex geometry. And if I have to create the hexahedral elements by slicing the geometry, it will take a very long time. So what we can do is, we can let the geometry be like this only and we can generate tetrahedral elements. But the tetrahedral elements that we generate must be of good quality. The second thing that we can understand over here is that the geometry is a symmetric geometry. If you see over here, according to this view triad, the geometry is symmetrical about the zx plane. Okay, so if you see the orientation of the zx plane, this geometry is completely symmetrical about the zx plane. So as we discussed earlier, whenever you create a geometry and you have to take that geometry for analyzing or for meshing, wherever it is possible to simplify the geometry, you should always simplify the geometry. Why? Because as you simplify the geometry, the complexity of the geometry will reduce and it will be easier for us to create the elements and to also perform the analysis. So in this case, as the geometry is symmetrical, what we can do is we can create a symmetric model. We can have only half of the model for analysis. The second thing is there are a lot of features over here. If you can see, there are a lot of hole features over here. There are a lot of extrusions, slots and everything. Okay. Now, whenever you create a geometry, there are two types of features in the geometry. Now, what are the two types of features? Every geometry will have two types of features, that is design features and manufacturing features. Now what do you understand by these design features and manufacturing features? Now first let us talk about the design features. Now assume you have a bracket like this. Okay. Now if you have this bracket, there is a sharp corner over here, right? So if I am applying some loads over here, this bracket will tend to bend over here. And because of that sharp corner, here you will have maximum stresses induced in this area. So to reduce the stresses in this area, what we can do is we can add a fillet over here. So if I add a fillet in this region, what will happen is the design will be much better and the stress will reduce over here, or the stress concentration which will be much better. Thus there will be no cracks developed. Because of the sharp corner, there are chances that there will be some cracks developed. So if I add a fillet over here, the stresses will reduce. So this fillet over here becomes a design feature which we have added as per the design, as per the loads. Okay, and then we have some called as manufacturing features, which are only there in the design for some aesthetic looks or for handling purposes. For example, if there is a plate, sharp plate with sharp edges, what we can do is, as these corners can get spoiled because they are sharp or somebody might get hurt by handling, what we can do is we can add fillets at the sharp corners. Okay, so what happens, this feature over here, these fillets over here, they are not contributing in the design part. They are only there for the handling purpose. So this becomes as a manufacturing feature. So if you have any manufacturing features in your design, now this you will understand, and you will have to understand this according to the design. You need to think whether that feature over here is a design feature or a manufacturing feature. Now let us assume, can you see these extrusions over here? You have some extrusions over here, right? Now according to me, now let us say these are only here for the design, for some purpose. It is not going to contribute in my design. So what I can do is I can remove these features from my design. Similarly, there is one slot over here. Again, if this slot is not necessary for my analysis, I can remove the slot over here. Similarly, I can remove these hexagonal cuts that are there. Okay, I only need the whole feature. I don't need these hexagonal cuts over here. So for this purpose, what you need to do is you need to use some tools over here in the design modeler to edit the geometry. Again, this is a part of geometry optimization. So let us understand how to remove the unwanted features from the design. So the first thing that I'm going to do is I'm going to remove these extrusions over here. For that, I will go into the create option and I will say face delete. In face delete, I'm going to use the faces. You can use your control key to select the multiple faces. And after that, you will say apply over here and we can say generate. As soon as you say generate, you will see that those faces have been deleted. Similarly, there are a few cutouts over here. Again, these are not needed. So here, what I'm going to do is I'm going to fill these with some volume. Okay. Now let us move to the next option, that is we have some hexagonal cutouts over here. Now let us say these hexagonal cutouts are not needed. I need the whole, but I don't need this cutout over here. For that, I am going to use the fill tool. Now in the fill tool, we have something called as the extraction type. In extraction type, you have two options, bicavity and bicaps. The bicaps option is generally used for computational fluid dynamics analysis. And in this type, what happens is wherever there is an empty area or an empty void, it will be filled with a volume, and that volume can be used as a fluid in the CFD analysis. In our case, we are going to use the option bicavity. Now, once the bicavity option has been selected as the extraction type, now you need to select the faces. So now I'm selecting these faces over here, one by one, and then I will say apply. But before we click on apply, please understand that currently we have only one body over here. But as soon as I say apply and generate, you will see that one more volume has been created. Now this volume has been generated over here. Now the same procedure you can use for filling the volumes over here also. So let us go to tools again, fill, bicavity, and we will select the faces again. Apply and generate. If you wish, you can also select the faces in multiple areas. For example, I can simultaneously fill over here also. Apply and say generate. So the volumes have been now created. Now we have one body, and then these are the filled volumes that we've got. Now I need to add these volumes in the gearbox housing. So what I'm going to do is I'll go to the create option, Boolean operations, and here you have some Boolean operations like unite, subtract, intersect, and imprint faces. So in our case, currently we need to use a unite option and then select the bodies. Use your control key to select all the multiple bodies, say apply and say generate. You can see that the hexagonal cutouts over there now have been filled. Next, what I'm going to do over here is I'm going to fill this slot over here. For the same, for this slot, we will use the same option, that is the fill tool, bicavity. I'll select the faces, apply, we will say generate. The volumes will be created again, and then again we will go to create Boolean operations and select the volumes again. generate. So you can see that the volumes have been created. So here what we are doing is we are optimizing the geometry as per our requirement. Wherever I feel that the feature is not necessary for my analysis, we are removing them and simplifying our geometry. If you see over here, there are two separate faces. So I'll use the merge face option and we will merge them. So now this face becomes one single face. Okay. So here you can understand that what we have done is we have created some editing. We have done some editing in the geometry. We have removed some features. We have filled some volumes, and we've also used the Boolean operation. Now, as we discussed that the geometry is symmetrical about the ZX planes, what we are going to do is, instead of considering the whole volume for analysis, we will only consider half of the geometry. For that, we can go to the tools page, tools option, and symmetry. Now here you have to select the number of planes by which you want to split the geometry or add symmetry. So currently I want only one symmetrical plane, that is the ZX plane, and then you have to select the plane. So here I am going to select the ZX plane, but if you notice that the ZX plane orientation is somewhere over here. So what we can do is we will have to create another plane in the center, okay, and then we will cut the geometry. So for that, let us first create the plane in the center of the geometry. Okay, so let us create the plane. Now I will create the plane using from plane option, and the from plane option would be the ZX plane. I want to offset the ZX plane, and the offset direction would be the blue colored axis is the Z axis. So I need to offset it in the Z axis, and the value will be -8. Why? Because the positive is in this direction, so I need to move it in the opposite direction, and we have moved it by 8 units, and we also generate. So the plane has been generated. Now again I'll go to the tools option, symmetry. I need to cut only about one plane, and the symmetry plane is the new plane that we created, that is plane 5. Apply, and I need to create a full body symmetry, and it is going to be for all the bodies. Generate, and that is the cutting plane. So I have the half body. Now this half body can be taken into the mechanical window. So we will enter into the mechanical window. The geometry will get updated. So this is the geometry that has been imported. And now you can create the meshing. So I'll click over here on the meshing. You can see that the symmetry plane or the symmetry region is highlighted over here, which shows that this is the half geometry that we have got from the design modeler. So you can click on the meshing and we can say update to generate the meshing. So as we have only used the update option, that means it is the default meshing that we've got. So what we can do is we can use the sizing option to give a default element size for the whole body. So you can click over here and you can say what should be the element size. Now currently if you say 3, the sphere is very large, that means the element size will be very high. So I will reduce it. Let us say it is 2, and or let us say it is 1.5, and let us update the mesh. So now we will get the entire meshing according to 1.5. Okay, you can see the number of elements and nodes generated, and you can also see the element quality. So here you can see the quality of the elements generated. Okay, and here you can see that these are all tetrahedral elements that we have got. Okay, so this is how you can optimize your geometry by deleting unwanted faces, by filling the volumes of by filling the cutouts or slots, and by creating a half model or generating a half model by using the symmetry tool. So from this you can understand that whenever you create a geometry, the first thing that you need to do is analyze your geometry, whether you can simplify that. And if the answer is yes, that you can simplify the geometry, simplify it. If it is symmetrical, create the half model or create the 1/4 model using the symmetry region, create the half model, then understand which are the design features, which are the manufacturing features. If you have some manufacturing features in your design, remove them and then take it into the mechanical model for generating the meshing.